Okay, in this video tutorial I'm going to quickly go over another type of reaction, what we call a decomposition reaction. So definition of a decomposition reaction is when a complex molecule breaks down into two simpler ones. So that could be a compound breaking into two elements, but it doesn't always have to be. It can just be a slightly more complicated molecule breaking down into two slightly more simple ones. So we've got an example here, the decomposition of sodium bicarbonate. Sodium bicarbonate is a fancy word for baking soda. So let's have a look at that. So guys, I've got a little video clip here. We'll just play that one. So you can see here I've just put a dish on a balance. I'm just setting it back to 0 so that we're not weighing the dish itself. But now I'm going to put some baking soda in the dish. So we're just weighing that. And it weighs 32.47. So try and remember that number, 32.47. Now we're going to take the dish and heat it over a Bunsen. All right, and I'm heating it here. I heat it for a little bit longer than I show, but you don't want to see me just watch me heating baking soda. You can actually see in the video, you might see some gas bubbles coming off from under the powder. Although it wasn't so clear. Now 31.322826. All right, you can see those numbers going down. So it's definitely lost in mass. It's definitely lost mass. And what's actually happening is it's releasing carbon dioxide. So some of that sodium bicarbonate is actually breaking down, and what it's doing is it's actually releasing carbon dioxide. All right, so let's write an equation for that. Okay, so I'll start by writing the word equation. So in an assessment, you'd probably be given this. So we've got sodium bicarbonate is actually breaking down into sodium carbonate as well as carbon dioxide. So plus carbon dioxide and water. So sorry, I couldn't quite fit it in all in one nice neat straight line. So plus water. So guys, now let's write that as a formula equation. So sodium bicarbonate is actually NaHCO3. Fix up my A there a little bit. Okay, NaHCO3. And if you look on the ion table, Na is 1+, HCO3 is the bicarbonate or hydrogen carbonate ion. So bicarbonate and hydrogen carbonate is the same thing. All right, and you'll see that that's a 1- ion. So they pair up like that. Okay, sodium carbonate. Oh, left off the E up the top there. Sodium carbonate is Na. All right, sodium. Carbonate is just CO3. But if we look on our ion table, carbonate is a 2- ion. Sodium is a 1+ ion. So it's actually Na2CO3. Now if you can't do that, go back and watch my video on balancing ions for writing chemical formula. I've got a video on writing chemical formula, and in brackets it says balancing ions. It'll walk you through how to do that. Okay, plus we've got some carbon dioxide. So you should know the formula for that one, CO2. Plus we've got some water, good old H2O. I think everybody knows the formula for that one. Okay, so now we've got to go through and make sure it's balanced. So looking at that, what looks like the sort of the most complicated one to me? Well, I think it's probably the first one here. So I might start with that. It doesn't actually matter too much what you start with, but if you had a single element, like if you had oxygen somewhere here, or something like that. It might pay to leave that till last because it might be just a little bit more simple to balance our equation if we leave that till last. But we'll see how we go. We'll start with this one, and let's get into it. So here, let's start with looking at sodium. I've got one sodium here, but I've already got two sodiums here. So I'm going to have to double this, put a big 2 in the front. So now I've got two sodiums. So for now, the sodiums are balanced. Okay, so let's have a look at hydrogen. So here, 2 lots of hydrogen. I've got 2 hydrogens. And on this side, coming through, there's only hydrogen in the water here. So H2, good. We've got 2 on each side. The carbons, so over here, CO3. So I've got 2 carbons, 2 lots of everything, 2 carbons. Alright, over here I've only got 1 there, and I've got 1 there, so that's fine, that's good. 2 carbons here, and we've got 1 there and 1 there, so together those make up 2 on this side of the equation. So they don't have to stay together as long as we've got the same number on each side of the equation. Let's look at the number of oxygens. So we've got 2 lots of 3, so that's 6. 1, 2, 3, 4, 5, 6 total. 2 lots of 3, O3. Okay, so I've got 3 here, O3. 1, 2, 3. I've got 2 here, so that's 4, 5. And I've got 1 here, 6. So that actually all balances. Now, if you've got different colored pens, you might actually find it easier to do it like this. Maybe we should do that in colors. So we'll just check that everything balances once. We'll go through that just once more really quick. So let me start with maybe a black pen. So sodium, 2 sodiums, 1, 2, 2 sodiums on this side. So yep, that balances. We've got 2 of each of those. Okay, hydrogens. Let's do those maybe in green. I've got 2 hydrogens here. 2 lots of hydrogen, 2 lots of everything there. And on this side, H2, that's the only place we've got hydrogen. So that balances as well. So happy with that. Cool. Alright, how about yellow? So over here, 2 lots of carbon. Remember, we've got 2 of everything with the big 2 in the front. And on this side, we've got 1 carbon here and 1 carbon there. So no big numbers in the front, no little numbers just after them, so only 1 of them. So I've got 2 on this side, and I've got 2 on this side. Happy with those. Okay, so have to use red. So for my oxygens over here, 2 lots of 3. I've actually got 6. 1, 2, 3, 4, 5, 6. So O3 means we've got 3 of them, but we've got 2 lots of everything. 2 lots of 3 is 6. So over here I've got 1 lot of 3. 1, 2, 3. Over here I've got 2. 1, 2. And I've got 1 over here. So total on this side, 3, 4, 5, 6. Alright, just like on this side, we've got 6 on both sides. Alright, so that's balanced. So that's our equation. Cool, I hope that helped, and we'll look at another type of reaction in the next video.